Okay, hello and welcome to my channel. Today we're gonna continue with the local picture of wave functions and we're gonna move on to the drawing parts. We're gonna take a look at a generic potential and we're gonna try to plot the energy eigenstates on it. Okay, so now I'll have a potential, something like this. And suppose you only have the potential, you don't know where the energy eigenstates are. It might be here, here, or like just up here. So what you would want to do is that you would want to draw these lines and speculate. So for example, you suspect that your E0 is somewhere down here. You would want to try and plot it. Well, okay, one way to plot it, you draw it straight down. Yeah, let's do this. Okay, suppose you draw straight down. Okay, this might be a little bit too small. Just forget this part and remember your turning point is here, but I would zoom in so your turning point would be larger than that. It would be somewhere here. Okay, sorry, my board is too small. Okay, so suppose you suspect your E0 is that line. You're trying to draw it. And remember, E0 is an even one. Okay, so you get something like this, go up, then here is gonna turn. Similarly, here is gonna go up, and then to here's gonna turn. Okay, now suppose, okay, this should meet up here. Suppose this turning force thing is not strong enough, and it, instead of meeting like that, it's gonna go straight up and doesn't meet at all. Yeah, so you see the problem now? It's just like the turning force here is not strong enough. Therefore, it is still gonna turn, but they are not gonna meet inside this region that we want. So that is bad. Now we gotta move on to another one. And you're gonna do this over and over and over again until you move to a point where, well, they meet. The turning force from turning points are strong enough. So you're gonna do this over and over again until you get something like this, which is your E0. Here it turns, this one here turns, and they meet, so there are no discontinuity. So that would be an example for the uneven state, and more specifically the ground state. Next, we're gonna take a look at an odd state and see how that works. So with odd state, you would first want to fix one point. So you have your potential here. Suppose you want to find E1. And with E1, you know that it's gonna flip. So you're gonna fix which head is not gonna flip and which one is gonna flip. So suppose you don't know it's gonna flip, you fix this one here. There would be two ways this could turn out. Could either be this, something like this coming in. So suppose you have this first, it comes in and goes like this. So the turning force here is way too strong. So it isn't an odd state and it isn't an even state. So it just produces an discontinuity in the middle, and this is not valid as we know. So no, the up one is eliminated. You only have the one down here. So with the one down here, you flip it and somehow, some way, okay, then this one is a bit, okay. The one down, you do that and you see that they actually meet. Well, in the middle, of course, my drawing is not that great. So that, something like that. This is the middle. It always meet at 0. So there you go. You flip it, you try it multiple times, and it turned out to be the solution. So that would be the general method for you to use to plot these energy eigenstates. You try it over and over again until it meets either like this, or something. Yeah. So that would be your method to plot these. And next, I want to have a brief talk about something called the shooting method, which is a way for you to turn these, well, turn the process of finding these eigenstates into like pure numerical values. So with the shooting method, let's consider potential. Okay, I don't think I have to do too much drawing since the shooting method is most of the time used in labs, meaning that you would have like technology, I don't know, to do that for you. So suppose you have this, you want to pick an even state. Now we're first gonna turn our time independent Schrodinger equation, as you know, is something in second differential. So this would equal to, okay, pretty kind of a weird way to do it. But yeah, this is your Schrodinger equation, and the only thing I want you to see here is that this is a second order differential equation. That's the only thing I want you to see here. So you would kind of want to, okay, you kind of want to put this into a first order differential equation. So I would like to pick phi to equal to the psi. So you turn this into a first order differential equation already. Now you're gonna put it into your computer or whatever, and it's gonna help you integrate numerically until the case. So you would be the one to pick the value here. You would try, it might enter then explode to infinity, enter then it looks like it's the case, but then it explodes to infinity. So you would want to put like a lot of values in here and try to pick the ones that actually the case, so the valid ones. So that's it for the shooting method. There are nothing much to talk about as the computer would do most of the work for you. So I guess that's it for today. Goodbye.